This video is kind of like an enrichment video, showing you some things about this graphing calculator that you can actually use to your advantage. Maybe not in class, but in situations where you might have a graphing calculator around and you need to get some solving done. So keep in mind that you all have done substitution before, box and switch, where you take this y and say that y is equal to this amount, negative 3x plus 17, and then substitute it up here. And so this box here turns into negative 3x plus 17 equals whatever's on the other side, which is 2x plus 2. From there, we can move our 3x, which is negative, by adding it, which gives us 17 equals 5x plus 2. We can subtract 2 from both sides, which gives us 15 equals 5x. And then when we divide by 5, we get the answer of 3 equals x. You then, based off of what we remember, is take this x and plug it in. So we rewrite one of the equations, y equals 2x plus 2. Take the 3, plug it in, and get the answer of y equals 8. And the answer is 3 comma 8, based off of what we know. Again, that was substitution, the way that we learned it. Some of us learned it just now, just this last few weeks. Others of us learned it last semester. So like I said, but we've all seen this part, so keep that in mind and remember that. Now the question is, how do we do this if we are looking at a graphing calculator to solve? So if you're using a graphing calculator, keep in mind that whenever you're looking at what a solution is, it means that if I have two graphs and lines and I'm looking for a solution, keep in mind that the solution is where the 2 points cross, because remember we learned that again when we solved by graphing. So using the graphing calculator real fast, let's look at this thing and see what's going on. So first off, you've got the first graph, 2x plus 2, and you've got the second graph, negative 3x plus 17. And when I go to graph this thing, you're going to see the first graph here, the second graph coming through somewhere, and notice that both of these graphs cross at a point. And keep in mind that from what we learned in systems of equations, this represents the solution of the graph. Well, we've learned about the calculate function, the blue part, but either way, calculate is one of the things that you can do with this graphing calculator whenever you're doing graphs. It's on the, if you look above the trace key, says CALC, which means like you're trying to calculate or find something special about the graph. And so what you'll do is you'll hit second trace, and we are looking for, if you just read this list, we know what we're looking for. We're looking for the line where the lines intersect. Now the way this function works, it simply asks you what is the first curve you're looking at. And we only have two graphs, so it's really nothing for us to do because it's going to naturally switch from one curve to the other one. But for the first curve, it's going to go ahead and put that blinking X. That's going to follow the line that we're looking at here, so you just hit enter to select that one. And it's going to ask you about what your second curve is, and it automatically puts the X on the other line. As you see, you now have the X on that one, so you hit enter again. Don't pay attention to the guess part, because again, the guess really doesn't mean much. It's just something that I still don't know exactly why it does what it does, but like I said, the guess part is what you ignore. You simply hit enter one more time, and you see the answer pop up as x equals 3, y equals 8, which is exactly what we found up here. That looks like a 1, but either way. So in other words, if you have this situation, the graph will actually find what's going on with that. Now the only reason why you can't use that with the other equations is because you would need to put this in slope-intercept form in order to graph it, to where you move 2x over and then divide everything by 3. But again, just in general, your graphing calculator finds the solution of those things. But that's not really what this is about. It's more about something else. It's saying that oddly enough, we can also use our graphing calculators to solve this equation here. So this is something that we learned how to do sometime when we had to distribute it and then put like terms together and then move the x's and do all that work. We have been taught how to solve this algebraically, but what if we simply viewed it as a system of equations where one equation, y equals this, the other equation, y equals that. think about it like this. This was a system of equations, and it turned into a basic regular looking equation that we found the value of x for. And so these two things kind of go hand in hand together. And so what we can do is we can simply say, you know what, I'm just going to view this as one line, I'm going to view this as the other line, and since this is equal, really whenever we find x, keep in mind all we're doing is finding a spot where both of these two things equal the same thing. And so again, identifying the solution would give us the value of x that makes both equations equivalent. So this by definition is a solution, so let's look at that now. So again, all I have to do is go back to my y equals and type in one equation, one side of the equation, 3x plus 4 as 1. Then type in the other equation, 2 times x plus 5 minus 6 as the other equation, and graph it. These equations now cross through, and there is a solution somewhere in there. Again, in order to find that solution, I want to calculate where they intersect, so second calculate, 5 for intersect, or you could just hit the button 5 for intersect. It's going to ask you about the first curve, but really again there's nothing to do, just hit enter. It's going to ask you about the second curve, same thing, just hit enter. It's going to give you a guess, but you don't care about, just hit enter. And the value of x that it gives us is, whoa, 0.4. That makes no sense. Hold on. I did this earlier and something else. Let's look at second trace again. Intersect. First curve is here. Good. Second curve is here. Good. There we go. This is actually, whenever you do your intersection or number like that, it's usually right around some other number. 3.2 e to the negative 13. I guess it is 0.4. I don't know how that works. I think it just messed up, and I hate whenever that happens on the video, on the camera. Let's go back to this thing and see. 3x plus 4, 2 times x plus 5 equals, or minus 6. Yes, I swear I just did that work. Anyway, let's try it one more time. That actually might be the answer anyway. Anyway, let's just assume that worked like it was supposed to, because maybe I just didn't check that when I did the actual answer on there. But let's look at these things here real fast. Sorry about that. That example was supposed to be a little bit more revealing and exciting than what I just made that. Let's just see if we can actually use that to our advantage instead. Let's say that you're having this here, and it's not so much that you don't have to do algebra anymore, but let's just see, let's find out if this actually works like it's supposed to. I hope it does, because it would be terrible to make this video up and not really have a point to make in the video. 3x plus 8 put on one side, 23 put on the other side, graph it. Second calculate the intersection, enter on the first curve, enter on the second curve. Look at this answer, and yes, this actually is doing what it's supposed to be doing. What you are looking for is the value of x that makes it the same, and notice when I found the intersection of those two graphs, it gives me x equals 5. Remember, we don't care about y. Y is actually what the value would equal, but what it's saying is that x equals 5. So if you go back over here the old-fashioned way and put a 5 in there, 3 times 5 plus 8, you see that it does equal 23, and so you just actually got the answer of x equals 5. So I guess I just made a crazy example. Sorry about that waste of your time, but again, that's pretty much what it was doing. Looking at number 2, same thing. If you want to know the answer to this just really quickly without having to go through a whole bunch of stuff, and you're taking an SAT, ACT score, bring up your graph, clear out all the graphs, put the left side in one equation, 5 parentheses 2x plus 1 minus 10, put the other answer in the other equation, 5x. So you got this one equal to that one, graph it. You see the two graphs cross, so you hit second calculate, find the intersection. First curve, hit enter. Second curve, hit enter. Guess, who cares about it? Just hit the button and you see you get the answer of x equals 1, y equals 5. Again, we don't care about that. What we do see is that x is equal to 1. And again, if we check that out the old-fashioned way, 5 parentheses 2 times 1 plus 1 minus 10, and then 5 times 1 on the other side. If you plug it in, it gives you the same answer there, which means that that is the solution you're looking for. This even works in proportions, especially if you know how to use fractions or remember how to put fractions in using your parentheses. So going back to the third one, on this side it's x plus 5 divided by 7. I have to make sure, because I want to keep this in one part, that I put the whole top part in parentheses. And so I'm going to put parentheses x plus 5, close it, and then divide it by 7. Again, what this views it as is, this is one big value, I'm dividing it by 7. And the other one, again, I have to kind of add in my own programming skill and put this part of the fraction in parentheses. So parentheses 3x plus 5 over 14. Again, graph that. Of course, the graphs aren't going to look great because they're just random, but the whole point of the graphs is for us to calculate the intersection. So I hit 5, first curve, second curve, guess. It gives me the answer, x equals 5, y equals something else that we really don't care about. The bottom line on this is that x equals 5. And if we look at this, 5 plus 5 is 10 over 7. 3 times 5 is 15 plus 5 is 20 over 14. And we see that if we actually reduce 20 over 14, it actually is 10 over 7. So there's your answer to your proportion without having to do the cross multiplication and all the other work. Even more, last example before I let you go, it even works with things where you don't like the fractions, to where you can also sit there and say, you know what, I don't like this right now, so I'm just going to do 1/3, and again, fractions go inside of parentheses. 1/3 x plus 3/2 is one equation. 1/5 x plus 2. Just as long as you type them in the right way. Again, 1/3 in parentheses, 3/2 in parentheses, 1/5 in parentheses. Graph both of those things. Let the computer or let the calculator go ahead and graph them the way they need to. See that there is an intersection point, which typically, unless the lines are parallel, there will be an intersection point. Trace the intersection 5. First curve, second curve, guess. You see that your answer is 3.75. Now here's the problem with the math that we've done. Again, it says 3.75. But in most situations they want a fraction, so that's where you have to go back to the other stuff that you were taught and turn that into a fraction by hitting math, enter, enter, to see that your answer is actually x equals 15 over 4. So again, it's not mandatory that you learn these things, but it definitely helps you to know how to utilize a tool that's on your desk. You don't have to be able to use a graphing calculator to show you, or sorry, you won't be able to use a graphing calculator to show your work, but the good news is if you're ever taking a test or anything, you can actually use it to check the work you did. So just remember, again, with any skill you have to practice it to remember it or get better at it. So you don't have to use what I just showed you, but I think that in certain situations, knowing how to do this as fast as we are, especially if it's something where it's an equation that's really, really complex and you just really don't want to feel like going through it, that just knowing that can actually help you out. So other than that, that is the end of this week. We do start a new section on Monday, so be ready to go.